Hello everyone and welcome to Tech Talk session 32, the last Tech Talk session of 2020. Our next Tech Talk session will be on January 7th, 2021. It will be Tech Talk session 33. We will be hosting AMSC's Commonwealth Edison, ComEd, to discuss their superconducting cable project that is currently under construction in Chicago. During that session, we will learn more about AMSC's superconducting cables and how they are being used to develop a resilient electrical grid. They call it REG, R-E-G, in Chicago. We will also be hosting Dan Botsman, Chief of Staff to the President and COO at ComEd, as well as Michael Ross from AMSC, who we met last week in Tech Talk session 31. Don't forget PDH contact hours. If you email myself or Matt, we will get you a certificate right after this presentation. Also, please share, hit that like button below, and please share with your colleagues these Tech Talk sessions. We put a lot of work into it, and we're trying to increase participation. Also, don't forget to ask questions during the presentation. We will get to your questions at the end of the presentation today. And don't forget what NEPSI does. NEPSI is a manufacturer of metal closed capacitor banks, metal closed harmonic filter banks, rated 2.4 kV through 38 kV. We're now part of American Superconductor, and American Superconductor is a manufacturer of STATCOM systems at the medium voltage level, 2.4 kV up through 38 kV. We have been learning about STATCOM systems in the prior Tech Talks, so if you want to learn more about STATCOMs, please go back to those Tech Talk sessions. NEPSI is also involved with what we call now hybrid STATCOM systems that consist of both passive and active solutions. We can extend the range of a STATCOM system to include our systems in addition to what AMSC produces. Today we will be taking an in-depth look at ABB's VD4-CS. Here it is. Here she is. It's a capacitor switch and breaker. So it's a capacitor switch and breaker, and it's keys, both a switch and a breaker that's well suited for the renewables industry. So in other words, well suited for 34.5 kV applications in North America or 33 kV applications in other parts of the world. We'll be hosting Andrea Ferruccio, Konstantinos, Papaschalis, and Victor Villanueva, all of ABB, who will provide a more in-depth look at the VD4-CS. So we will have them on in just a moment, but first we're going to review what's here. So the VD4-CS is well suited for the renewables industry. It's got short lead times. They're stock at NEPSI. That's key, they're stock at NEPSI. It's a transient-free point-on-wave switching device. In other words, it's a zero voltage closing device. It's transient-free. There is no need for transient inrush reactors, and Pete will pick this up. During Tech Talk session 2, we talked about transient inrush reactors, and when you use standard circuit breakers or standard switching devices, you need to have transient inrush reactors to limit the magnitude in the frequency of the inrush current associated with back-to-back switching. So in capacitor banks like this, where we might have 10 megavars and 10 megavars, we would need to have these, and these can get quite big in the renewables industry because it's very common for us to have capacitor banks that routinely exceed 10 megavars in rating. This is the VD4-CS. It's 38 kV rated, 185 kV BIL, 31.5 Ka interrupt rating, and it has a short time withstand rating of 40 Ka and a peak making capacity of 104 Ka. It's got an electrical endurance of 10,000 operations, capacitor switching current of 1200 amps, and that's significant when you think about it. 1200 amps could switch 53 megavars at 34.5 kV. So we're going to review the install, and Pete is here with us today. You've all met Pete during in-post testing and the CT testing, so he's going to talk to us a little bit about, well, how do we install this? So Pete, why don't you talk about lifting it first? How do we lift this thing into our enclosure?
All right, so the way this thing comes is it comes on a pallet just like this. You're going to have to unbolt the breaker from the pallet, and this is one way that we lift the unit. So there's a spreader bar, and on each end of the breaker there's two lifting eyes. So two lifting eyes here, two on this side. We tie a sling up. We tie a sling up and around, and we'll use, depending on the position, we'll use a fork truck generally and hoist it up this way, and then bring it over to the unit and put it into the unit.
So I asked the question, does this spreader bar come with the VD4-CS?
Sometimes it does, sometimes it doesn't.
Okay.
It's an optional adder.
All right, so it is 507 pounds, so it's, or 230 kilograms, so it's not exactly a light piece of equipment here. So incidentally, it's rated minus 20 degrees Celsius to 55 degrees Celsius. So in North America, we can easily get to minus 20 degrees Celsius. So Pete, what do we do when we have cold temperature environments where the temperatures can get, say, below 0 degrees Celsius?
So there's two things that we do. One thing is we'll install a box heater inside of the mechanism inside of here with a thermostat. That'll heat the internals of this guy. We also put in a under temperature thermostat in there also to monitor the temperature, just in case there's a failure of the heater circuit or the temperature gets below enough where it could be an issue with the operation of this. So it's a protective mechanism. The other thing we also do is if it's a super cold environment, saying it's going up into Canada, into northern Canada, we'll insulate the whole enclosure on the inside as a second line of defense, and we'll heat the internal compartment of where the VD4 is located.
We actually put a permissive into the control circuit to prevent operation under a cold temperature environment, right?
Correct. That's the under temperature protective feature.
Okay. So maybe you can just talk a little bit about the voltage sensor here, the location of voltage sensor, phase rotation, things like that.
Okay, so the voltage sensor, this is a voltage sensor. This is a low voltage sensor, a 15 kV sensor. Basically the same sensor as a sensor that is located internal to the capacitor bank here. The sensor always has to go on the left pole, so it's normally A phase. Left pole is normally A phase for us, but that sensor has to connect on the line side of the switch on A phase to this pole, the first pole on the left.
P, is there any restrictions on the capacitor bank connection, grounded versus ungrounded? Oh,
yes,
delta.
Yes, it has to be Y ungrounded.
Y ungrounded. And then if you could speak a little bit about phase rotation. You mentioned that the sensor must always be on phase A. What about phase rotation?
So phase rotation, you either have A, B, C rotation or A, C, B rotation. So as long as you have the sensor on A, whether this is B and C or C and B, it doesn't make a difference because of the operation of the switch, which you will talk about how the switch operates.
Yes, it's ABB will be involved with that.
Okay.
More in-depth discussion, yes.
But basically, this senses a peak. These two will close when the voltages are equal, and whether this is B and this is C or C and B, it doesn't make a difference on these two. So that's why phase rotation does not matter.
All right. Maybe you go under the hood a little bit, Pete, and show the inside of this this breaker.
So there's two screws that hold this thing on here, and the cover. It's a little tricky getting the cover off. You've got to kind of hold this pigtail up. Paul, maybe you can just hold that up, and then I won't look so clumsy. When you hold this up, you gotta lift it out. All right, that's a little difficult. Okay, so
That's not your average. It's not your average breaker, is it?
no. So what you're looking at here is there's three servo motors. There's a servo motor for phase A, a servo motor for phase B, and a servo motor for phase C. Each of these servo motors are driven by a card, a CPU card. So there's a card here for this servo motor, a card here for this this card for this servo motor and this card for this servo motor. Then there's a CPU for operation of the VD4. So one of the things you note is this thing's really built with a lot of quality. There's basically like military connectors everywhere that's connected here, and it's a very well built breaker. One of the things you notice here, there's a safety interlock switch here. So if you pull the cover off, this will trip the breaker. We got it taped closed right now because we're in a testing phase, so it's taped closed so we can pull the cover off and still operate the breaker.
Why don't you talk about the indicators? I know there's three indicators here.
There's three indicators because these are independent, poles closed independently. They're not mechanically linked to one another. There's an indicator for each pole. You know, so when this breaker operates, this mechanism will go up and down, and it'll tell you whether it's closed or whether it's open. On each of these poles, there's also an A and B contact that's located right at each pole here. So these A and B contacts are indication of each pole. And then through the electrical diagrams, which Paul may be going over in a little bit, these three poles are brought out to tunnel blocks, and at the same time, they're also brought together to gang together to give you the overall indication of whether the breaker is open and closed. So you can look at all three together or each of them individually.
And incidentally, I think it's worth noting that because it's point-on-way switching, you got to have independent pole operation. Otherwise, you wouldn't be able to individually control each one. So, AP, I'm going to go to the other side and just operate the breaker so people can hear it operate. It's not the standard sounding breaker.
So you might want to note the breaker's in the open position right now, so you'll be able to close. You should be able to close it.
All right, here we go. Yeah. Okay.
Okay, so one of the things when you zoom in down here, you can also see there's an operations counter. It gives you the number of counts. You can see that when the cover is on the breaker also. So these are visible, and so is the operation counter visible when the cover is on. There's a capacitor in the back here. That capacitor has stored energy, so if there's a loss of voltage, there's enough energy to trip the breaker in the loss of voltage scenario.
All right. Okay, so we're gonna get anything else?
Yeah,
couple more things. Okay.
So couple of neat features on this breaker is there is a quick disconnect. So let's just say this, for one reason or another, had need to be replaced. There's no wiring that's required. You basically would go into the unit, you would unclip this, pull it out, pull the whole breaker out, and then put a new one in. So it's got a quick disconnect on it. It would be pretty useful if you needed to get a unit back up and running. That's it.
Okay. So we're gonna bring on ABB now. We're gonna be bringing on. Let me find myself here. We're gonna be bringing on Andrea Ferruccio. He's in Italy. Konstantinos Papaschalis and Papaschalis. And Kostas, you have the most difficult name in the world. And then Victor Villanueva, all from ABB. They're with us today to give us more insight on the VD4-CS. So, hey guys, welcome to the Tech Talk.
Thank you, Paul. Thank you, everybody, for this great opportunity. This is Andrea Ferruccio from ABB, located in Italy and responsible from product management of the breakers and switches for special application. And specifically today, I'm really eager to present you, to bring you in this journey, in this quantum leap brought by the VD4-CS features and values. Thank you, everybody. Kostas.
Hey. Thank you. Thank you for coming on, Andre.
Thank you, Paul.
Kostas.
Thank you, Andreas. Yes. Kostas is fine. Kostas Papaschalis is my full name. But no worries, I understand the
5 syllables. You get 5 syllables in your name. That's not usual.
All right, not a typical name. So my name is Konstantinos Papaschalis. I'm working in the marketing department of ABB, and I'm responsible for the panel builder program manager. Victor.
Victor.
Hey, hello everyone. My name is Victor Villanueva, and I'm a product marketing specialist for ABB. Joined ABB this year, and I'm super excited today to join this call and to talk about this exciting product VD4-CS.
So why don't I'm going to have Andre kick off the presentation, and I'm going to head back up towards the office while he presents.
Yeah, sure. Thank you, Paul, for this introduction. Really, really interesting. Thank you very much. And for this opportunity, because really here we have today the occasion, the chance to look at not just the breaker, I would say here we have the opportunity to look at a solution. Solution specifically designed for, let me say, facing and solving, again, all those phenomena that are appearing, undesired phenomena that are appearing where a capacitor bank is normally switched. We all know the importance, how crucial is a capacitor bank in its network. We all know, thanks also to Paul, how important is the role of a capacitor bank. But in principle, however, due to its, let me say, physical characteristics, whenever we switch, we open and close a cap bank, so means capacitive load means capacitive current, something happens. Something happens that is not desired. Something happens that can really, really have an impact, maybe on the short, maybe on the long term, on the capacitor banks themselves, but also on all assets connected to the same network. So thank you in advance for your interest, for your attention. Here, this is the start of this journey. Walking through, we will see what brought us to the finally release of not again just a product, to a solution. The first step in this journey is to understand exactly what are these undesired phenomena that we are talking about, the transients. The transients are phenomena that are appearing again during the switch of a cap bank, a typical cap bank in medium voltage, and due to its physical characteristics, this phenomena should appear and should be eliminated in some way. Now, what are we talking about? What are these typical phenomena? Transient means temporary effects like the inrush current, which is maybe the most important one. The inrush current has, as you can see here, a lot of undesired effects on, again, not only the cap banks, but especially on the windings, on other assets of the network, something we need really to avoid, we need to limit in some way. In some cases, we are able nowadays to do that via using some additional components like inrush reactors, some other solutions. Here, we want to present you something that really eliminates finally the inrush current effects, and also all those additional components so far needed to limit the magnitude. Not only inrush current, all those, consequences, subset linked to the inrush currents, like disturbances in the voltage, not only, also such kind of loss availability of the devices due to these whole undesired effects, something that now, finally, we can really eliminate thanks to the use of the VD4-CS, a totally innovative, totally new solution in the field of medium voltage capacitive banks switching. How can we do that? We have identified your challenges using cap banks, switching cap banks. We can now identify what is the solution. VD4-CS is the solution. Why? Because it is a circuit breaker, a complete circuit breaker, based finally on the innovative technology of the noise-free switching, the synchronization. This means that exactly as Paul and Peter were anticipating, we know the breaker knows exactly when it needs to open and to close in order to eliminate such transients in current and in voltage. Then we can implement this technology thanks to the advanced kind of actuation system used, but not only. We have a totally new type of control and monitoring of the technology inside the breaker. And thanks to all these technical features, we can finally really bring you something that is valuable, cost saving, space saving, because in principle, eliminating specifically the inrush current, we can tell you, look, you can avoid all, again, those that I just mentioned, additional components like inrush reactors needed so far for limiting the currents. Well, you can eliminate them, benefiting directly of a cost saving and a space saving, space needed so far for installing them somewhere. And I said the inrush currents have such kind of effect, maybe on the longer term, of the capacitor banks on the assets of the network. Eliminating these currents, we can really offer you finally the possibility to count on an increased lifespan of the capacitor bank themselves. Well, reducing the inrush currents, reducing phenomena, transient phenomena, noise in the network, we can finally, thanks to the VD4-CS, also guarantee you the reduction of the possibility of an outage, which is also bringing, this possibility is also bringing cost, very, very sometimes heavy cost in the balance. Then we can offer you something that is so reliable that really we can count on something like a step ahead from this point of view, from this perspective, from these situations. Reduce the risk of outages, increased operation cost, because the assets will benefit of an increased lifespan, not only from, let me say, from the network point of view, but also, as we can see in a few seconds, also the breaker can really offer to you a real quantum leap in the on the perspective, from the perspective of the mechanical and the electrical endurance. Best network quality, best complete relay and protection and selectivity. We can really improve the behavior, the way we manage the network where these capacitor banks are installed, thanks to the all these features that I just mentioned, but also we are considering, we are treating with a breaker, with a complete circuit breaker, complete then of switching features, protection features, able to offer you the reduction of a total investment, thanks to and also the others clearly due to the improved protection range. As Paul and Peter were saying, this VD4-CS can count on really additional features also from the protective point of view. It is fully tested for covering the highest level of capacitive current to be switched, and also short circuit events to be protected from. Some real technical characteristics of VD4-CS breaker: complete circuit breaker based on the innovative solution of the synchronization strategy, completely embedded in the breaker itself, counting on an innovative servo-motor actuation system and new vacuum interrupter technology. All this specifically designed and assembled in order to guarantee you not only, again, the solution to an issue so far linked to the transients during the switching of the breaker, but also values, quantifiable values, cost saving, hazard risk reduction, thanks to innovative breaking through technology, all embedded in one single solution, the VD4-CS circuit breaker, protection against transients during the switching, protection against short circuit events. Increased lifespan, as I said, up to, we estimate 10%. Cost and space saving, thanks to the elimination of all those components, able to protect so far and to limit the inrush currents. Then, Thanks to the synchronization, thanks to this new product, we can eliminate inrush, we can eliminate noise, we can have finally the extremely low probability of rest strike with an improved protection range. All in just one solution, completely interchangeable, as you can see from the picture, with a typical VD4, standard VD4. From the dimensional point of view, it is completely interchangeable, has also the more or less the same footprint. Inside this circuit breaker, that's the magic. Able to offer you again a quantum leap. I will be never tired to repeat a quantum leap in the switching and the protection of the capacitor banks, thanks to the implementation of the unit synchronization, thanks to the fact that we can protect you also against short circuit up to 32 kA at 38 kV voltage, rated voltage, with the highest, really very high capacitive current, ability to switch a very high capacitive current up to 1250 amps. That will result, as you can imagine, in a very large amount of capacitive energy, capacitive power that can be managed with just one unique solution. Thanks everybody for your attention. Then it will be really a pleasure for me to answer to all your questions and doubt. Thank you.
Wow, so that's impressive. Very nice presentation, Andre. So maybe we did a video a while back of us doing a very simple timing test. Would you mind me showing that video?
Yes, please.
Okay, it's just a 3-minute video. Then we're going to come back with some questions and talk some more with the three of the ABB folks. So we'll be right back.
Sure.
Let us show this video. Hello everyone, Paul Steciuk with Northeast Power Systems. We are continuing our evaluation of the ABB VD4-CS. It's a transient-free breaker, a transient-free switch for switching capacitor banks. This is a 20 megavar capacitor bank. We're doing an evaluation of the closing times. We want to show you how the technology works. So I'm going to first talk to you about the setup. Okay, so what we have is a 3-phase capacitor bank here. It's 20 megavars. We have a voltage sensor on phase A. This is part of the ABB switching device. And we got the VD4-CS, the 3-phase device. We're referencing the phase A, B, and C voltages here. The way this operates is Pete will initiate a closed signal. We have voltage sensors on the load side of the VD4-CS located here and also on the neutral. So we're recording the waveforms with a transient recorder. We're injecting voltages with a 3-phase voltage source on the line side of the VD4-CS. So the way it works is that when we send a closed signal, 200 milliseconds later, we'll see that the phase B and phase C contacts close. We're going to see that on the transient recorder. And then 90 degrees later, we're going to see phase A close. So this is interesting to watch. And it's very consistent, the closing time from the initiation of the trigger or the close signal to the time that it actually closes is 200 milliseconds. So very consistent operation. One thing about this switching technology you have to remember is that it does require phase A, B, C rotation. The capacitors must be in an ungrounded configuration as we have shown here. And the voltage sensor must be on phase A. And this is how we have it set up. So Matt will go in and look at the transient recorder while Pete gets prepared to energize the system. So here we go. So we're going to turn the transient recorder on. Ready? Fire. Boom, you see it. Okay, so you're looking at the voltage signals. You can see here that we have the blue and the magenta phase has closed. Blue and magenta is phase B, phase C. It closed when the B and C values were equal. In other words, 0 voltage closing. B and C are both closing at the same time. Thus, transient free between phases B and C. Then 90 degrees later, we have phase A closing. Phase A is the orange.
It's the yellow.
Oh, yellow. Phase A is, okay, is orange from my perspective, yellow. So yellow is closing here. So you can see that operating. The green is the neutral. And you can see that the neutral tracks along 0 because we're monitoring the neutral voltage during the closing operation. So the phase A, when it has come into when it was switched in, is exactly 0. So the switch is performing correctly. So we have done this many times. We've done the evaluation, and it has performed quite well. So we're going to continue to evaluate this technology. We will continue to update you on this technology as we learn more about it. Stay tuned in. Okay guys, that was an interesting video. We did that a few months ago. We actually put that on LinkedIn during our evaluation of this VD4-CS. So I wanted to show the audience that quick presentation. So we're going to cross over and show a drawing of this VD4-CS incorporated in our design here at NEPSI. So I'm going to share my screen, and we'll come over to a quick PowerPoint, a quick PDF file. So this is a 3-stage capacitor bank consisting of 3 stages of 13.4 megavars. So it's quite a big bank, typical for renewable power plants. This is a 3-line diagram. Power cables come in through a set of roof bushings, and we got an overhead bus bar within our metal closed system. And we have 3 VD4-CSs here. And they feed the associated 13.4 megavar capacitor banks, 3 of them. So it's a relatively large bank. First thing to note is there are no transient inrush reactors. That's the cost savings there. And the other thing to note here is we have a voltage sensor on phase A. And that voltage sensor is on the line side of the VD4. That's the first thing to note. And the other thing to note is it's an ungrounded Y cap bank here. So I'm going to flip over to the next page where we can show the control drawing here. And this is a pretty typical control diagram for a circuit breaker. It has a lot of the same elements a standard circuit breaker has, but it has other things like a watchdog type information in the CPU, and perhaps maybe we can get ABB to share some of that stuff with us. But here we show that there's a power supply coming in here. There are 2 open inputs. We can open this breaker through 2 different inputs, input 1 here and input number 2 there. So we typically use 1 for protection and 1 for control. So in this case, we're using open number 1 for control. You can see there's a push button up here to close. And we also use an interlock scheme for that, and we do a remote open through SCADA, so we're allowed to do that there. You can do the same with the close here. We have a close command coming through here, and that's done through remote SCADA or done through a local command here. There's a close enable for which we have jumpered out, but we could use that close enable for any given function. And then we have sync status. The VD4-CS has the ability to monitor for sync status. Is it synced with the system? Are we going to be doing 0 voltage closing? And we have the ability to prevent the breaker from operating if we don't have synchronization in the closing direction. Incidentally, it always acts as a breaker in the open direction. It's going to trip open. It's not going to look for synchronization. It's only on the closing operations that we look to do that. You have a watchdog device here, and then you have your standard A and B contact arrangement here. So when you look at this diagram, it's very much like a standard breaker. It's very easy to incorporate into existing designs. So we'll come back. So that's the entire thing. Let me come back with Kostas too. So anyways, guys, I think we're ready to take questions from the audience. We'll go to a question screen, and we'll review the questions and come back to the participants of the Tech Talk to answer questions. right, guys. Okay, so I'm back. We're back. We looked at the questions, and before I get going with the questions, I'd like to first put up the contact information for Andre, Kostas, and Victor. So give me a moment here. We'll kick over to a quick slide and show. There we go. There we go. So Victor, Kostas, and Andre's contact information, their email addresses. So Victor's in Houston. Kostas is, where's Kostas? In Lake Mary still, and then of course Andre in Italy. So reach out to them should you want more information about acquiring these switches for your applications. We're going to come back to three of these guys, and you can then ask some questions. Here we go. All right, so hey, Andre or Kostas, would you like me to first read the question and then you guys answer, or would you want to field the questions yourselves?
Paul, just one comment before we go to the question. I would like to really thank you, first of all, for putting this together, and then I'm always impressed positively with the quality of the solutions that you are providing, but even more about your knowledge, both for the components that you are integrating and of course the application. So it's really great, and the sessions you are doing have been very helpful and educating for myself. I'm really learning a lot, and I really hope it's the same for the other viewers. So really, thank you.
Well, I appreciate that, and of course we've had a long-standing relationship with ABB. It's been well over 20 years now, and it's been a great relationship. You have a great OEM staff, and it's great that you're coming out with new products. That UFA system, the DS1, and now this VD4-CS are three great products that we've been integrating into our solution. So we really appreciate your support, and Kostas, especially you. We've been working with you for a long time now.
Thank you, and all the team, of course.
Yes, and thank you, Andre and Victor. Okay, so would you want to field the questions, or you want me to read them and you respond? What do you think?
I think
we can go with whichever you think it's more important, more relevant to your customer. So you can address the question.
All right. I'll read the question, and then maybe somebody can chime in on your side. So we had first questions from Ivan. Ivan says, "Hi NEPSI team, could you expand a bit on the maintenance needed on the mechanism, servo motors, etc., and if there's any settings that need to be done prior to operation using these boards?"
Yeah, I think I can take it, Paul. This is really, really interesting question, because finally it demonstrates and allows us to demonstrate that we are treating with a totally different type of device, of a circuit breaker. The VD4-CS is based, as you correctly said, on servo motors, and the servo motors, being basically an electromagnetic machine, does not need any kind of maintenance. For this product, up to the 20,000 operations, mechanical operations. This is really, really important to underline, because no maintenance means, in principle, very high level of reliability along its entire mechanical life. In principle, so it's a cost saving for any maintenance activities that could be, in principle, foreseen along a standard, let me say, solution. Here we have really the possibility to count on the highest level of reliability given by this really innovative type of actuation. Thank you.
Yeah, I might add, the control is all integrated into that breaker. There is no separate control, no separate controller, no separate relay. Yeah.
Absolutely, absolutely. You will receive, correct, Paul. You will receive a device, a machine that is fully tested, fully controlled, fully configured to finally offer to you, as I said, the maximum level, the highest level of reliability, all the values that I described coming from the control switching for this really dedicated application like the capacitor switching, capacitor bank switching is.
Andrea, if I may add, especially also on Paul's comment, because of the VD4-CS is a closed loop system, in reality it learns every after operation and it adapts and it adjusts itself for the different condition and the different loads and different characteristics it might encounter. So you don't need any kind of calibration later on like you might need with alternative technologies. So it's a maintenance-free system. So you don't need to do any, let me say, follow-ups to verify and check. The system will tell you if it needs anything.
Hey, Kostas, I got a question that kind of pops in my mind. When you order a VD4-CS, do you order the voltage sensor separate, or is it automatically included with the VD4-CS?
So the way we manage it, you are ordering the VD4-CS and you will receive already the right sensor. So it's already part of the package. You don't need to think about what kind of sensor you need to choose, what any other, let's say, different consideration. You will both receive the two items together as a package. And this is also the way we are quoting. We are considering the same price for the breaker and the sensor.
Okay. So we're on to Ivan's another question. Okay, thanks for the explanation. Okay, so Wesley had asked a question: is there sufficient stored energy in the capacitor to perform an open close open operation per IEEE switchgear requirements?
I can take it again, Paul. This is a really interesting question because, again, just to for the full overview, yes, exactly. The VD4-CS is based, including an internal capacitor, an internal capacitor that is giving a certain amount of energy helpful during the operation, and clearly it is fed, it is supplied by the auxiliary circuit of the circuit breaker itself. Once this auxiliary power, this auxiliary voltage is off, then clearly the capacitor will discharge. Well, one important point is that the VD4-CS is designed to work under the assumption that after each operation, the capacitor bank is discharged. And for doing that, after every opening operation, we should wait for 5 minutes, as normally, accepted, 5 minutes for having a close. The energy of this internal capacitor of the VD4-CS will stand for 1 or 2 minutes. So we will not have the possibility to close in this this couple of minutes, in this short period, because we would find the capacitor bank still charged. So in principle, the energy kept by the capacitor, it stands for a shorter time than what is normally done, what is normally waited for another closing on the capacitor bank itself. This is the usual practice. Yeah.
Okay, great. We're going to move on to the next question. I think you answered this question from expanding on the question about the DC power. You did answer that, yes. So why is a servo, next question is from Wesley, why is a servo motor the choice of the drivetrain for the breaker versus a magnetically actuated device like the ABB AMVAC uses?
So let me take that, Paul. So in ABB, I think we are the only company that we have the most different and versatile products when it comes to actuation technologies. I think we have managed to have products with spring-actuated breakers, we have magnetic actuated breakers, and we have now even servo motor actuated breakers. So all of these technologies have plus and minuses when it comes to performance and application and, of course, cost. Now, AMVAC is a magnetic actuated breaker. Magnetic actuation is very reliable and it's also maintenance free, so you don't have to do maintenance. But when it comes to capacitor banks and synchronization application, you need that extra level of precision. And having a servo motor technology here, it's very, very, very important to have very, very good control, very precise opening, very precise closing, because you really need to hit these these right times, and how Andrea was explaining during the presentation, but also how you saw on the video. You need to have a very precise system that operates not only when you just install it, not only when it's new, but you need to adapt throughout the different environmental conditions, warm, cold weather, or the aging of the product. So the servo motor technology, because you are literally controlling the servo motor live when you are doing the operation, but you can also adjust afterwards and improve and accelerate or decelerate during the operation. We think it's the ideal solution for a capacitor bank application.
Okay, great. Okay, so next question. The operating energy is capacitor based. How long of a life for the capacitors?
Yeah, I can take it. The capacitor, the internal capacitor we use for the continuity of the operation of a VD4-CS is the very, very high level, high performance capacitor that can surely last for this, well, long-lasting, along the long-lasting endurance life prescribed for the VD4-CS. So it is for sure can be guaranteed for exactly for the same operations of the VD4-CS up to again 20,000 operation mechanical ones. Thank you.
Okay. So next question from Wesley again. Does the unit, does the VD4-CS simply do a calculation of position of phases B and C based on voltage sensed on phase A and then actuate accordingly? Can you give some details on the controls and operation?
Yeah, I can give details very, very precisely. That's right. It's right to talk about the calculation. It's right to let me say, to talk about a measurement, a precise measurement of a reference, a voltage reference, done, again, as we said, via a sensor on the phase A. However, in principle, Paul, I would highlight the word precision, because the measurement can be done, but if it is not done with the highest level of precision that we can guarantee, thanks to the advanced control of the VD4-CS installed in VD4-CS, and also the precision during the actuation guaranteed by the VD4-CS, thanks to this servo motors, this newly introduced actuation system, then we could not do anything. The key word here to achieve the highest level of, again, precision in elimination of the inrush during, for instance, the closing operation is really, really possible, thanks to the combination of these two, let me say, aspects, these two features of the VD4-CS, and the precision in achieving them, in applying them. The precision in the measurement of the control of the voltage, the reference given by the A phase, as I said, elaborated by the electronic, elaborated in order to give exactly in a certain moment, the exact moment when it is needed to be done, the input, the closing input in this case, to the phases to close in order to eliminate the inrush. This is the principle. Going into some more details, I would say, and specifically during the closing operation, we take the reference of the voltage on the phase A when it is at the peak. We know that we are treating with absolutely a balanced capacitive load, capacitor bank. Then we have the strong assumption that we have this voltage reference on the phase A, and we know exactly subsequently the voltage value on the phase B and C. Then the difference between these two phases, the voltage of these two phases is exactly zero, and exactly that moment is the best one when we need to close on these two phases. And then subsequently we know, because thanks to the electrotechnics, we know that the voltage on the phase after a quarter of period will be zero, and again precisely we know that this moment is the right one when to close also the phase. So in this way we basically apply the synchronization strategy in the most precise way possible. Thank you for the question.
If I may add, Andrea, and for our viewers, it's very important to clarify that the VD4-CS should be installed only for capacitor loads, because as the comment was correctly mentioning, we will take the input of the voltage on phase A, and then we calculate every voltage, every phase voltage, and also the current and all the calculations. So you need to have this fully balanced load, and you need to have a poor capacitive load when you are using the VD4-CS.
Maybe I will add just a little bit then. So frequency makes a difference, right? You have to specify 50 or 60 hertz when you order the VD4-CS, correct?
That's absolutely correct, Paul. Thank you.
Okay, great. Okay, so on to the next question. Okay, early in the presentation, we heard phase rotation does not matter, but in the second part, it did matter. Can you clarify?
If you want, I can take it, Paul.
Yep.
Basically, we need, as I said, again, a fixed reference, which is basically the voltage, again, on the phase A. This is the one to which we have connected, we need to have connected the voltage sensor. And this is exactly, this was exactly the message. Until we have the connection, the fixed reference of the voltage on the A phase, then we can clearly having a balanced capacitor bank connected in a certain way, in a precise way, means ungrounded Y, which is the most common one. Then we know that the behavior of the other two phases, and we can act again precisely according to the synchronization strategy implemented.
Yeah, maybe the reference is the difference between ABC and ACB, but the reality, you're sensing phase A, and then you close B and C. So it doesn't matter if it's CB or BC. It doesn't matter. You're closing when those two are equal. So the phase rotation doesn't matter. The requirement is that the sensor be on that leftmost pole of the VD4-CS, correct?
That's correct.
Yeah. Okay. Okay, so on to the next question. Okay, I may have missed it, but what is the percent of the typical cost savings from a traditional comparable product for both CapEx and OpEx?
I think we can. I can ask the Kostas to integrate here. Thank you.
Yeah, for sure. So it's a difficult question in the sense it's very difficult to give a precise number without knowing the full scope of the project. But what we are normally doing is when you have a project, we can analyze how often you are switching, what kind of loads you are putting, how many steps of your capacitor bank is doing, and then we can somehow estimate how much you would save if you go with VD4-CS or if you go with a traditional technology. Of course, there is normally, I would expect, a little higher aspect on the CapEx, but then you will see a very significant savings on the OpEx because of the maintenance-free aspect, because of the savings on the technology, because of the safety, that you are not putting your people in harm doing maintenance, and all the nice things that Andrea said. I would also like Paul's comment here, because Paul has better view on the whole project as the capacitor bank manufacturer, and maybe Victor, you have to add as well something here.
So from our standpoint, the cost, the raw cost, is about the same to comparable technology. So when we're looking at different switching technologies, if you're looking for transient free switching technology, there's a limited number of devices out there at this voltage level. The choices are few, and the cost for those different technologies are about the same. So really you're looking at other factors when considering the switch, and they would be service, they would be lead time, performance. These are other factors to be thinking about. So service, the warranty, performance are three key items, and lead time is a fourth item that I would say should be a strong consideration. because if the costs are the same, then the next thing is, okay, what about these other factors? What should we be looking at?
Glad to hear. So pure
Yes.
savings.
Yeah, yep. Victor, did you have anything on maintenance or?
So one thing I did want to add, Paul, is that, so just want to highlight that this unit is VD4-CS is a switch and a breaker as well. So it's it has a 31.5 kA rated breaking capacity. And by having that, in some of the applications, you might have a feeder breaker feeding the bank, the cap bank, and you might be able to eliminate it because you have a breaker within this unit. So that right there, Intel is a huge cost savings.
Okay, good. Okay, so we're going to move on to the next question. This one's from Ivan. Okay, so looking at the VD4-CS flyer, it is mentioned that a new type of vacuum interrupters are used on the breaker. Can you expand a bit on it? What is the difference versus a standard vacuum interrupter?
Yeah, I can take it, Paul, and thanks again for this question. It is really technically interesting, I would say. We have to consider that everything in the VD4-CS is new and dedicated for a specific, very specific application, which is the switching of the cap banks in order to, as we said, eliminate the transients we normally experience during the opening and closing of such load. For doing that, as I explained, we have new actuation system. We have specific, very precise control in the actuation, in the reading, in the measurement of the references and the voltage and the electrical parameters. And we have also new innovative vacuum interrupter technology. Going into many details, unfortunately, is not possible because it would take really long time. However, would you be so interested in having more details? I'm really eager to invite all of you in a dedicated, let me say, dedicated session for discussing about the innovation brought by the VD4-CS entirely in all its aspects. Thank you.
I want to go back to the OpEx question, the CapEx question, just a moment. I forgot a detail. So remember, we had warranty, we had lead time, we had performance, we had service. A fifth item that really to think about is the VD4-CS is both a breaker and a switch. If the interrupt rating is within the short circuit rating in the system, this VD4-CS can be used as not only a switch but also as a breaker. That can eliminate the feeder breaker to the capacitor bank. So that can be a cost savings. So I forgot to mention that. That's a key item on this VD4-CS. So we'll move on to the next question. Adding on to Wesley's question, how does any distortion between the three phases in reality affect the performance if the calculation is used for B and C phase?
Quite interesting. Thank you for this question. Again, really technically deep and interesting. I would say the VD4-CS, as we said, is counting on the balancing of the load, of the capacitor load, assuming some kind of waveform. And as you correctly said, Paul, also it depends also on the value of the frequency. Having some unbalancing means, for instance, the presence of some harmonics. Look, no problem, absolutely no problem, because we are here to evaluate also, whether with you, also those specific need of some plants, of some applications where, for instance, the waveform of the main electrical parameters are not exactly sinusoidal, and are not, for instance, at 50 or 60 hertz, but with some harmonics in between. So we are here to support, because together with the product, together with this solution, we have a very strong knowledge and experience, technical experience, in order to evaluate any possible deviation from the nominal behavior that we expect from the electrical parameters, and how to approach them in a way to suggest you the best solution, even in those cases. Thank you.
Okay. Yeah, so a general comment here, if you see that your system somehow deviates from the standard application, please come to ABB, let us know what is your system, and I'm pretty sure our technical expert and our team can really go in detail to see what is the deviation, how strong it is, and if it's good to use the VD4-CS or any other product that we think it's the right one for the specific application.
Yes, I might add also that if the voltage distortion is in that 5% range or less, which is typically what's considered acceptable, and the unbalance is within, say, 1% for voltage, which is normally would be already a high value. So in those cases, I would think that the crossing point where B and C cross each other would not be significantly changed at that point. It would be very close. You wouldn't see much of a difference there. But that's something that maybe somebody would have to plot and see how much variation you get.
Yes.
Yeah.
I would say it's difficult to give a rough or a rough estimation, but I think the right way to proceed is bring us the case and we will do the analysis. We can really calculate, simulate. We really know how exactly all the components of the system behave, and then we can say, okay, this is not significant, or look, it is significant. You might have some issues with the performance or not.
Okay. So we're going to the next question. Next question is there any redundancy should the sensor on phase A go bad, if it were to go faulty? Is the operation of a VD4 relying on this sensor essentially?
The VD4-CS is counting on the input signal of this sensor as a reference, as I said, for the establishment, the application of the synchronization strategy. I would say, yes, there is no redundancy in case of faulty sensor. However, we have tested under really severe condition also this sensor, and I would say this is basically granted for, again, as for the servo motor and the capacitors, or for the entire mechanical and electrical life of the VD4-CS tool. So, in principle, yes, there is just one sensor, not on all of three phases, just one, because it is enough to have it, because according to the assumptions, we have the reference of the first one, and then we can assume and establish the value instant by instant of the other two phases.
Andrea, I would call also a redundant system the fact that the VD4-CS is also a breaker. So you don't really need an input of the voltage sensor in order to open and operate. So in case you have an issue on the sensor and you see no voltage, or you see voltage that has strange values, the VD4-CS will be able to operate and clear the fault, or put your system in a safety condition, and then you can, of course, go see what's wrong with the sensor, what's wrong with the other components. So we are definitely have this redundant, let me say, operation, but clearly, if you don't have a sensor, you cannot expect to have synchronization and normal operation there.
That's correct.
Andrea, I don't know if you mentioned, because I was reading as you were talking, you do have a sync signal that comes in, and we do have the option to switch without synchronization and with synchronization. And I'm not sure if you mentioned that or not.
Oh, yes, it was not mentioned, and you are right, Paul. Thanks. In principle, we can really operate in two ways. Why? Because we have two different inputs for operating, as you correctly said, in a synchronized mode and also in the simultaneous mode. Simultaneous opening is particularly crucial when, again, as Kostas was describing during the fault, for instance. During the short circuit events, again, the VD4-CS, we can count on the VD4-CS thanks to its short circuit braking capability. And then clearly the short circuit event will be cleared in a simultaneous way. Means without any synchronization, the breaker, once it will realize that there is a short circuit, it will open all three phases altogether. The synchronization instead is clearly working during the switching of the nominal capacity current, which we have up to 1250 amps, which is very, very high. And we have also the possibility to switch it, to open it via in a non-synchronous, in a simultaneous way, using another input, another opening command, which is basically the redundancy of the first opening input we have on VD4-CS. We have a second one that we can use. The user can use directly by inputting a command or opening command in case no synchronized operation is needed in that moment.
Great. All right. Good. Next question from Wesley. In the case of multiple stages with back-to-back switching, is it customary to use the VD4 for all stages or to mix an ABB device by using both the VD4 and VD4-CS, right, and then the DS1 for the other stages? I think maybe there's an opportunity here just to talk about VD4, VD4-CS, and DS1 and HD4, maybe 10 seconds on each to talk about each device. From our standpoint, we would typically not mix within the same piece of equipment. I would tell you that, but maybe it's an opportunity for you just to go through those other switches real quick, just to clarify what they are doing. It's maybe small differences.
Yes, a quick comparison. We are talking about mentioning VD4-CS and DS1, talking about two products that are basically for different applications, for two different, let me say, voltage level and also type of installation. The VD4-CS is a complete circuit breaker. Complete circuit breaker basically counting, then offering them the possibility of the switching, transient free switching, and the protection against short circuits. The DS1 instead is a pure switch. The difference also is the fact that we are using the address the VD4-CS for all those applications with capacitor banks ungrounded Y with voltage level up to 38 kV. The DS1 can reach typically 15 or 17 kV voltage levels. Kostas, Victor, any further comment from your side?
Yeah, one comment from my side in case there is some kind of misunderstanding. First of all, we have another Tech Talk that we spoke about the DS1, so I invite all your viewers to go also see this Tech Talk. I think you will learn a lot about DS1. Now, when we go to VD4-CS and which product is the best, I would say we are talking about two different applications, two different voltage levels. For example, I would not use the VD4-CS together with DS1 at the 15 kV application. You are using an over-dimension switch there, so you can go to switch your load with the DS1. In case you need protection features, you can consider VD4-CS or just an ADVAC breaker or any other circuit breaker for the protection of that load. So we don't typically see, let's say mixing these products. Most probably you will see only VD4-CS for the 38 kV application, and depends on the solution. I think it's better to go with one product, but yeah, if we see like a very specific application, we might consider deviating from this approach.
Okay, on to next question. I think it might be the last. I think the lab experiments shown earlier can incorporate performance tests for unbalanced distorted voltages at the input. Okay, so I think that's correct. We could advance our testing to include distortion with a test set. Maybe we will take that on, or maybe ABB will take that on. It's actually some good testing to do.
Yeah, would be really interesting. And also we can count on the fact that we can test, surely, as you said, Paul, but we can also simulate. We can understand through modelization, through analysis, through simulations, calculations, what could be the behavior, the impact of this different behavior, different from the nominal, of the electrical parameters like the voltage due to some fluctuations on the let me say on the functionality of the bank during the switching, and then we can even do this kind of theoretical evaluation thanks to the above mentioned knowledge and experience and we have built so far in our company. So thank you.
Okay, it was Tech Talk session 6 that I had you guys on for the DS1. So, guys, I'm going to flip over to another screen just for a second. It's a do's and don'ts screen. I always do at the end of my presentation. Then I like to come back to you guys and wish you farewell. And maybe a couple questions will pop up from my do's and don'ts screen. And then we'll end our Tech Talk today. So just a moment, I'll be back with you. Okay, again, this is the contact information for Victor, Kostas, and Andrea. And let me see if I get this. So it's my do's and don'ts screen. I like to do these at the end of each and every Tech Talk. So first, if you want this VD4-CS, specify metal closed. At the moment, it's the only way this switch is available. So if you want to use the VD4-CS, make sure you specify metal closed because you need that enclosure. If lead time is a concern with the use of an alternate switching device, specify the ABB VD4-CS. Why? Because it's stock at NEPSI. We stock this switching device. Consider using the VD4-CS as both a switch and as a feeder breaker for capacitor banks. The VD4-CS does both functions very well. I always often say, think about the collector bus, which commonly picks up your collector system cables. Consider that flowing into the capacitor bank, picking up a couple more breakers, 1, 2, 3, or 4 breakers that pick up capacitor stages. They can be considered breakers and switches. So you can eliminate the upstream feeder breaker that commonly feeds those capacitor banks. So on the DOTE side of the screen, don't specify transient and rush reactors. They're not required. The VD4-CS is a transient-free device, and as such, transient and rush reactors is not required. Back to that CapEx question, OpEx question, this is another savings. You do not need transient and rush reactors. In the renewables industry, it's very common that stage sizes can get up to 15, 16, 17, 18 megavars per stage. Back-to-back switching transients can become quite significant. That transient inrush reactor can become quite substantial. So the VD4-CS eliminates that large transient inrush reactor that would be required if we were to use just a standard breaker or switch. Those specify 200 kV BIL. Remember, the VD4 at the moment is 185 kV BIL. If you specify 200 kV BIL, you're boxing us out from being able to use this VD4-CS. So 185 kV BIL is the preferred impulse level. We would go further to say specify 150. The IEEE, IEC, CSA standards do not require 185 or 200. In most cases, 150 is sufficient. If you specify 150, we can get other advantages. One of those is we can put the disconnecting switches in our equipment also. The disconnecting switches are the ABB Versaruptor that we use, an externally operated air disconnect switch and ground switch that allows us to provide and integrate that into our capacitor bank, eliminating more cost and more site work. So 150 kV BIL allows for that. Don't over-specify the short circuit current rating. We oftentimes get specifications and they automatically go to 40 kA. We go back to the customer and say, can you confirm 40 kA? Will 31.5 kA be sufficient? And oftentimes the answer is yes. So if you specify 31.5 kA, we can use the VD4-CS as both a breaker and a switch. So it gives you some cost savings because, again, we can eliminate that upstream feeder breaker. And don't forget, if the fault current is above 31.5 kA, you can still use the VD4-CS. Why? Because there's a 104 kA peak withstand current and also a 40 kA 2-second rating on that switch. So it can still be used for the purpose of switching. We just can't use it for interruption. So I'm going to go back to Kostas and to let me do this and get Kostas back on. Okay, guys, I think maybe we have a couple more questions. I'm not sure if you could hear my do's and don'ts screen, but let me see. One more question came in from Rob. In some cases, reactors are used to avoid amplification of harmonics. How do you avoid harmonic amplification with this solution? I can answer this if you want.
Yeah, please, Paul.
Yes, okay. So So remember, we have two types of reactors that are used in the metal close inner open air solution. One is transient inrush reactors, which is used to decrease the magnitude and frequency of back-to-back capacitor bank switching transients. They're typically on the order of about 100 microhenries at the 38 kV level. They are not tuning reactors. They're not a 5% or a 7% reactor or a 4.7 tuning reactor. They are transient inrush reactors, and the microhenries are quite low. When you're talking about mitigating harmonics, you're talking about filter reactors, tuning reactors that typically would tune the banks to a frequency typically on the order of 4 to say 5th harmonic, 4th to 5th harmonic. And a lot of times that's to prevent resonance. Remember, filters are installed for 3 reasons. One is for power factor correction. 2 is to prevent resonance, and the 3rd is actually to reduce voltage distortion. But the second one, prevent resonance, is to prevent amplification of the harmonic current. So that's the iron core reactor that does that. That is an independent issue to switching transients, and that's really what I'm trying to get to here is harmonic voltage distortion, harmonic filtering, and harmonic current amplification is a issue related to harmonics and the capacitor reactance and the capacitor bank resonating with the source impedance is not related to switching transients, which is what this switching device is doing. We oftentimes would see both this VD4-CS applied with a harmonic filter, which would contain that tuning reactor. So good question. So I think that's all the questions. I appreciate you guys coming on and giving us more insight into this switching device.
Thank you, Paul, for hosting us. First of all, happy holidays. We are almost there.
Yes.
To our viewers, stay safe. I know you have a big storm up there in New York today, so please stay safe. And of course, Merry Christmas.
Yeah, we got a almost I would say 24 inches, 2 feet, maybe 2/3 of a meter. So it was quite a bit of snow.
It's sunny here in Florida.
Yeah, Lake Mary. I know you got it good down there. So, okay, Victor, thank you. Andre, thank you.
Thank you, Paul, for this great opportunity. Again, it's the second time for us to have this kind of event, and always I enjoy it, and I appreciate really the opportunities that come from this kind of chances. So thank you very much, because the cooperation with you is really great. Thank you.
Yes, and Victor, I'm going to have you back on for the ultra-fast earthing switch, the ABB UFIS system. So this is another great technology. So you're on the hook for that.
Another great product. Yeah, I'm looking forward to it, Paul. Yes. Thank you so much.
Okay, guys, we'll see you. Happy holidays. And
happy holidays.
All. Thank you.
Yes, we'll see you.
Bye-bye.
Whoa, full. Okay, there we go. I'm at the controls today. Anyways, guys, happy holidays. Thank you for tuning in to Tech Talk session 32. And we'll be back on January 7th, as I noted earlier. We're going to have American Superconductor back with us. We're going to be meeting with both Commonwealth Edison, the CEO of Commonwealth Edison, and also Mike Ross again to talk about the Chicago REG product, the Resilient Electrical Grid, and the use of their superconducting cables to improve the resiliency of their grid. So we'll be back on January 7th with them. We look forward to coming back with you.